Alright, so here's your problem. For part A, find the sum of the first n terms of the geometric series, and for part B, find n for the given sum s sub n. And the sequence given is 1 plus 4 plus 16 plus 64 plus, and it continues. A, the n that's given, the n value that's given here, is n equals 14. So it wants us to add up the first 14 numbers, or wherever n equals 14. And so let's go ahead and figure out what this sequence is here. Let's see how this pattern's going. So we have 1, 4, 16, and 64. So 1 times 4 is 4. 4 times 4 is 16. And 16 times 4 is 64. So basically what's happening is we're taking the number and multiplying it by 4. Whatever, so we're going to have taking the previous number, right, and multiplying it by 4. Now there isn't really a function in this kind of summation notation. There isn't a way to say, take the previous number and multiply it by 4. So the best way to do this is to really look at your equations and figure out what do you have and what would resemble this. So the one that actually resembles this is r to the k. There's a summation of k equals 0 where it goes up to n, and it is a times r to the k, where r is some constant and k is our counting number. So let's go ahead and test this out. So for our first term, let's set r equal to 4. So we're going to have r equals 4, and we're going to have r to the 0, right? And that's going to equal 1. And 4 to the first power is going to equal 4. 4 to the second power is going to equal 16. 4 to the third power. Now if you notice, this is 4 to the first. 4 times 1 is 4. 4 times 4, which is 4 squared, is 16. 16 times 4, so you can say that this is 16, not 14. 16 times 4 is 4 to the third. And then over here you can say 4 times 4. So if you notice, we're doing basically what we had set up before. 1 times 4, 4 times 4, 16 times 4. We're just multiplying the previous number. So as n increases, we're using this previous number kind of thing. All right. So this is the series. This is the type of problem that we're looking for here. Let's just go ahead and clear all of this. All right. So this is what we have. And a equals 1. So r equals 4 and a equals 1. Sometimes you might change a, you might not. In this case, a just equals 1. And that gives us the problem that we want. So for this case, our problem for part A, let's go ahead and do that over here. For part A, we have the summation as k equals 0. K is our first value, whatever it is. And n will be 14. So as n goes to 14. So we're going to write this as 4 to the k, whatever k happens to be. K can be n, whatever. It's the same. It's this value that counts. It increases by 1 each time, right? So now, if you look in your book or in your notes, you should find an equation that says that this is equal to 1 minus r to the n plus 1 divided by 1 minus r. Alright, so that's it. This type of problem here would equal this. Let me show you the base equation. There's going to be an a out in front, so if you have some a value, it's going to be out in front, and it's going to be a times 1 minus r to the n minus 1, plus 1 to the n plus 1, divided by 1 minus r. Alright, so this is just what the general equation looks like, but for our case right now, we don't have an a, so this is what we're using up here. Alright, so now let's go ahead and plug in this value and see what we get. So we have 4 to the k, and our final value is going to be 14, so we're going to plug all these numbers in. So we're going to have 1 minus our r is 4, n is 14, so it's going to be to the 14 plus 1 divided by 1 minus 4. So let's go ahead and grab our calculator here. So let's go ahead and do the top part first. We're going to have 1 minus, actually we're going to off parentheses here, 1 minus 4 to the, now 14 plus 1 is just 15, to the 15th power. Let's go ahead and close those parentheses. And this is going to be divided by 1 minus 4 is just negative 3, so 3 negative. So this is the number that we get. This is the value you get when n equals 14. So let's go ahead and plug that in here. So this is going to be equal to 3, 5, 7, 9, 1, 3, 9, 4, 1. So let's throw in some commas so it's easier to read. 1, 4, 9, 3, 1, 9, 7, 5, 3. Right? So this is what the summation as k equals 0 and 4 to the k as k goes from 0 to 14. So this is the summation of 4 to the k as k goes from 0 to 14. That's how you would read this. And this is equal to this number here, which is 357 million and, more stuff. So this is part A. This is the solution right here to part A. And really the hardest part here is identifying which type of summation we're going to be using. And really the best clue that you have is what equations are given to you. What do you have? So this is definitely something that you need to memorize. Right here, these different summation equations, where you're going to have the sum of something is equal to some equation over here. Alright, so you definitely need to memorize those. That's really important for this part of the class. Alright, so now for part B. Part B wants to know, so let's go ahead and pick a different color here. Part B wants to know what is n, so what is n, it's a question mark, what is n when s sub n is equal to 341. Alright, so this is pretty easy. All we do is s sub n, if we go back to this equation up here, so this equation up here, this value over here is nothing more than just s sub n. This is what s sub n is. It's that final value. It's the summation of all of the n values. Alright, so we can go ahead and say s sub n, and they tell us that s sub n is equal to 341. Let's go ahead and scroll down a little bit. So 341 is equal to, and we go back up to this equation here, 1 minus 4, alright, and n is, we don't know, we're actually solving for n, so it's going to be n plus 1 divided by 1 minus 4. Alright, so after this is just algebra right here. So 1 minus 4 is going to be negative 3, and 4 to the n, this is just going to be, to get rid of this plus 1 right here, so this little plus 1 here, all that is 1 minus, we could say 4 times 4 to the n. So that kind of drops that plus 1. That plus 1 might add some difficulty later, but all it is you take a 4 and you multiply it to the front. So it's 4, so let's write this down here, 4 to the n plus 1 is nothing more than 4 times 4 to the n. Alright, it's just simple exponential property right there. Alright, so now this is what we have. So let's do 341 times negative 3. Let's go ahead and grab our calculator here. 341 times 3 is going to be 1023. So this is going to be equal to negative 1023. And this is going to be equal to 1 minus 4 times 4 to the n. Alright, so let's go ahead and subtract this negative 1 here. So we're going to subtract negative 1 from both sides. So this is going to become negative 1024 is equal to 4 times negative, sorry, don't drop that negative, negative 4 times 4 to the n. Alright, so again, so let's pull out the calculator. 1024 divided by 4 is equal to 256. So let's go ahead and scroll down here. So if we divide this 4 to both sides, this is going to be positive 256 because we have the negative value here and the negative value over here. So positive 256 is going to be equal to 4 to the n. Alright, and we just finished covering logs, so what we're going to do here is log base, how do we want to do this? Figure out the base in a second. So log of 256 is equal to n times log of 4. So actually base doesn't matter. So what we're going to end up doing, and I'll show you why right now, we're going to have, so we're solving for n here, so let's go ahead and divide log of 4 to both sides. So log of 256 is equal to log of 4. Whenever you have a log over a log like this, they just combine. So this is going to be equal to, we've done this before. No, just kidding. They're not going to combine. This is actually a ratio. So you can go ahead and just plug this into your calculator. We don't care what what the base of the log is. So this is going to be, let's clear this. So 256, the log of 256 is that number divided by the log of 4. That's going to give us 4. So that's just log of 256 divided by log of 4. So the bases don't matter at all. All it is a ratio between those two crazy numbers. So as you saw me clicking, you saw these long decimal numbers. It's really just the ratio between the two. So log of 256 divided by log of 4 is equal to just 4. Alright, so let's go ahead and come back here. So that's going to equal to 4. And we divided the log of 4 to both sides. So 4 is just equal to n. So S sub n is equal to 341 when n equals 4. So if you want, you can go ahead and plug this back into the equation we have up here, and you can go ahead and find that. So this equation here, so if you really want to, you can go ahead and plug those values into here, where n is equal to 4, and you can go ahead and test out that problem. Alright, but this is how you would approach a problem like this. When it comes to, when they give you some n value here, so they give you n equals 14, first you gotta find out which equation you're using. So this is really the first step here. This is really important. So you want to find out what equation you're using, and then after you find out what equation you're using, after that is just basic algebra. You're given some equation over here, you plug in your values, you solve, you just throw it into your calculator. It might be really big, might be really small. And after that, for a type of problem like B, you do exactly what we did over here. You plug in whatever number you get for S sub n, alright, and then you go ahead and plug in whatever your remaining values are, and the only value that should be left is n. And that's what you're solving for, so that makes sense. Alright, so you just do some algebra. Most of the time for anything like this, there's going to be exponents, so you're going to use logs. So this is really where logs come in handy from what you've learned before. Alright, so hopefully this helps, and good luck on your homework.